9-7 is looking at solving quadratic equations using square roots. And this works really well when b equals 0. So in other words, when there's no x term. So if you have a quadratic with something like 5x squared plus 7x equals 9 or something like that, doesn't work well when you have an x squared and an x to the first. But when you don't have this middle part and you just have a 5x squared equals 9, or you could take and maybe say 5x squared minus 9 equals something, then that works really well. So that's kind of where we're going today. I want to first get into kind of this big thing right there. What's kind of like the big thing that people mess up on? And it's going to be this. If you were to look at the square root of x squared, or the square root of anything with an x in it that's squared, that has to equal the absolute value of x. And the reason is it gives two solutions usually, pretty much usually all the time, almost all the time, gives you two solutions. And here's why. You don't need to write this, but I just want to kind of make a point. If I were to have x squared equals 25, well, x could be 5, because 5 squared is 25. But x could also be a negative 5, because negative 5 times negative 5 gives 25. So we need to have two possible answers for x in this case, a 5 and a negative 5. Where if you're just going through and saying, ooh, I could get rid of the squared by square rooting, when you do that, you would end up with a 5 over here. So it can't just be x equals 5, because that would only give one of the two solutions. That's why when you do the square root of x squared, this here, you have to have that equal the absolute value of x. Because now, well, you could put a 5 in for x, and that would give you 5. But x could also be a negative 5, because the absolute value of a negative 5 gives you the 5. If that's a little bit blurry, don't worry. We'll do some examples here, and that should help everything make sense. All right. So if we want to go through and solve this bad boy here, we want to get it to a step, something like I had here in blue. I want to have x squared by itself equaling some other number. So first step in this one then is going to be 2. Say, all right, I want to get x squared by itself, so I add 169 here to cancel that out. But to keep it equal, I need to add 169 to the other side. That leaves me with just an x squared on the left side, 169 on the right side. And I can say, all right, to get x by itself, I have to undo squaring x. So I do the square root. Again, do the same thing to both sides to keep it equal. And the part that's easy to forget, the left side now becomes the absolute value of x, and that has to equal 13. And now, like when we were doing solving absolute value equations before, we could say, well, x could be one of two things. X could be 13, or x could be a negative 13. So those then are our two x-intercepts, or two answers for x. All right, next one. If we have an x squared plus 7 equals 7. We want to go through the same steps as we did before. We need to get it to where we have x squared by itself equaling some number, so we can do the square root. So I first need to get rid of the 7 here. So I'm going to subtract 7 from both sides. That gives me an x squared equals 0. And now to get x by itself, I need to undo the squared, so I can square root this baby there. And the square root of x squared gives me absolute value of x equals, square root of 0 is 0. Then, say, well, I could break this up. Some of you already see kind of what's going to happen, but essentially this is going to be the situation that I stumbled over before when the usually thing. There's only one answer, there's only one solution. And you get that because it equals 0 here, so you can't come up with two different numbers that would equal 0. X just has to be 0. All right, example 3, make it look a little bit beefier, but really it's the same kind of thing as what we just were doing with one extra step. So looking at this here, we want to get x squared by itself. So to solve for x squared, we need to do order of operations in the opposite direction. So I first do my adding and subtracting. And that will cancel out my minus 49. Leaving me a 16x squared on the left side equals 49. And where it may be tempting to go through and start doing square roots and stuff, and I suppose you could if you're real careful in this case, but it's going to be easiest generally if you keep going until you just have an x squared by itself. Now you have two options here. You could take and do 49 divided by 16, do 3.0625. That's what most people do. And then they do square root of both sides, and you get absolute value of x equals a 1.75. And because absolute value equals that, we can break this up into two different things. And one option for x could be a positive 1.75, or, because it's union, x, what's inside the absolute value could be a negative 1.75, because absolute value of that would give me the positive 1.75. So that's the way most people are going to work through to the solution. If you want to do it a different way, you could take this and not change it to a decimal. So if you wanted to, you could rewrite that line as x squared equals 49 over 16. So instead of taking that decimal 49 over 16 and making it 3.0625, you could leave it there. And if you didn't have numbers that were perfect squares, you might recognize 49 is 7 squared, 16 is 4 squared. So if you have perfect squares like that, you can look really suave and cool if you go through and then say absolute value of x equals 7 over 4, which happens to be 1.75. So you could leave it as a fraction if you wanted to, but like I started saying, at least, if these aren't perfect squares, you're just going to get like an ugly decimal over something else, and then it's easiest to go to here. But I would recommend, if you have a fraction, do square root of the exact number. Don't round this to 3.1 or 3.06. Keep the whole decimal. And if you have like a really long decimal, then you could just do second square root, and then do square root of your answer, so it has all the digits in. You don't have to type it all in again. All right, moving on. Then, garden wall is twice as long as it is wide. The area of the garden is 572 square feet. What are its dimensions? All right. Well, if it's twice as long as it is wide, we're all about finding x. So I'm going to say its width, maybe we'll call x. And then if it's twice as long, its length has to be twice that, so its length will be 2x. So if you could look at it as though you have this garden wall, then that maybe is a x by 2x. All right, we want to find the area. We know the area is 572 feet. Would you agree area is base times height? So I could say 2x times x, or length times width, you could say, but that's going to give me the area of 572. All right, so then we could go through and say, well, what are its dimensions? Well, this, do you agree, is 2x squared equals 572. And now we're just back where we were doing the last few questions. We start there and we go through, all right, let's solve for x squared. So divide by 2, I get x squared equals 286. And then I can go back and do square root of both sides. So that gives me absolute value of x equals 16.9. That's with a little bit of rounding, 16.91591, whatever. Okay, so 16.9. And if I were to take and break this up, x could be 16.9, or x could be negative 16.9. And a lot of people, they just go through and solve it like this without really thinking about what does the domain have to be. Well, if x is going to be the width of my garden wall, does it make any sense to have a garden wall that's negative 16.9 feet? Nope. That's what they call an extraneous solution. That's a solution. It's a legitimate solution to the math problem, but it doesn't make sense logically. That 16.9 can't be a length of a wall. So then to go through and solve this, all right, so the width is going to be 16.9. We just keep the positive one, and that'd be feet. And the other dimension, if you wanted to say by, the length we had was 2x, so I could do 2 times 16.9, and that'll give me 33.8. So our garden wall, 16.9 feet by 33.8 feet. All right, couple more to go. Let's dive in. This next one, it might be tempting to try to solve for x, but x is kind of stuck inside here. And you could FOIL this thing, so 2x plus 4 times 2x plus 4 and FOIL it. Then you're going to get something with an x squared and an x term. So if you have everything else, if there had been like plus 7 here, you'd want to go and subtract 7 from both sides. But if you've simplified it so the whole left side is squared, then go through and do the square root of both sides. So we'll say square root of this and square root of that. And when I do that, square root of 169 is going to give me 13. And the square root undoes the square here, so it leaves me with absolute value still, but absolute value of everything that was squared. So absolute value of 2x plus 4. And you solved these earlier this year. It's going back to like chapter 3 though, I think, or chapter 2 actually. And that gives us a 2x plus 4 equals 13. Or 2x plus 4 equals a negative 13. And now we just go through and solve like we've been doing for years. So you go through the order of operations backwards for those. That'll give me a 2x equals 9 over on this one. Or a 2x equals negative 17 here. And then divide by 2, divide by 2. Do the same thing in the other problem. I get an x equals 4.5, or x equals negative 8.5. So those are the solutions to that one. And last but not least, we get kind of a weird one here. Go through and, well, solve it like normal. We want to get whatever squared, or the x squared by itself. So I subtract 7 from both sides. X squared equals a negative 3. Then I could square root, because I have that all by itself. That's going to give me absolute value of x. But here's the weird part. Some of you, if you plug into your calculator square root of negative 3, it's going to give you like a decimal and then a kind of a italicized I at the end of it. I just punched it into mine right here, and it says error non-real answer. So if we go through, if we have this negative number, we're trying to square root it. We're saying what number could you multiply by itself to give you negative 3? That's what the square root's doing. And there isn't any real number that you could multiply by itself, because a positive number times a positive would give you a positive number for here. A negative times a negative would still give you a positive here. So this one here, there's no real solution. So you could say it does not exist if you wanted to. There's at least no real solutions. And when you get to Algebra 2, you start to get to play around with imaginary numbers. I always got a kick out of them. For now, you could just look at it as when you have that line x squared equals negative 3. X squared is going to give you a parabola, has a vertex at the origin that opens upward, and you're trying to figure out when does it equal negative 3. Ooh, that's not a very horizontal line. But so you're trying to figure out when does it equal that thing there, and it won't. You know, that it doesn't go down into those negative numbers. So there is no number for x, no x value on this parabola that would give you a y value down here. All right, that's it for the section. Let me know if you have questions in class. I'd be glad to help you. Have a great day.